so let's start our lecture today. So let me first get this camera right. Okay. Okay, good. Okay, let's start. So, I think where did I stop last time? Okay, so last time we defined like a points x1 through xn in this K, right? So such that this K is equal to the union of J from 1 to n wxj, right? So where this wxj is like the okay, the wxj is like the intersection, right? So the intersection of this uxy's. Okay. Okay, so okay, so here we say that if okay okay, so maybe let's start here. Okay, so here if this small gamma is in the big gamma, and okay, and gamma x will be y for some pairs of points x, y, k. For some pair of points x, y in this K, then okay. Okay, so then you have this x is in wxj. So remember that these xj's, they are one of the index that gives a finite cover of this k, right? This xj is like the neighborhood of the finite index point. And then, which is, yeah, also this is the, yeah, okay, and then, which is a subset of uxjz. Okay. Okay, so okay, and y is in vxzg. and gamma is in G x a z for the index J in the set 1 through n, like the n index set, and some point z in this y x j.
And then small gamma is in
G of x.
JZ. Yeah, so remember that this GXAZ is being defined as so this set, remember, it's defined to be the set of all small gamma in this big gamma, such that this small gamma of u of xy it intersects v of xy. So this is u here. This is v of xy. It's not empty. Okay, it's one of the
yeah, it's one of the intersection realizing maps. Okay. Okay. So okay,
and then okay, so yeah.
So you may wonder what, yeah, let me think. For some index,
okay. So for some index J in 1 through n,
and some point z in yxj.
okay. Okay, so let's see what happened next. So, okay, so here you have some piano point x, y, k. Okay, because yeah, so we know that x is in this wxj basically by the covering property, right? And then we know that by definition, this w of xj is equal to like the intersection of what? Yeah, so this xj is equal to the intersection of this y in yx, where u of xy.
So remember that this yx is what? This yx is okay.
So this yx is a set where
it's a finite set. Okay, says that
yeah. So where this yx so it's the finite set such that so you always fix an x first, right? So for fixed x, for a fixed x, this yx is a finite set such that so k is contained in this union of y in this yx v of xy, where the v of xy is the neighborhood of this y.
such that this set G of
xy is finite. Okay. So this neighborhood u of xy and v of xy.
So for any point xy, remember we choose like neighborhood of this u of xy, v of u of xy of x, v of xy of y.
So this v of xy is the neighborhood of y, right? So it's the neighborhood of y, and then this u of xy is the neighborhood
of its x, and then such that these two neighborhoods have the property
that this G is not empty. Okay.
Okay.
So this is the setup here. So, and then, yeah. So this, we know that this Wxj is definitely contained in each of these sets, right? And yeah, and then this Y is equal to V of wait. So if you have R, if it's a small gamma, it's equal to big gamma, and gamma x equal to y for some. Oh, okay, I see. Then x, okay. For some index, okay. Yeah, so this is true, like, because this is a covering. Because this is a covering, so this F must be contained in one of the coverings. What of the open sets? And then let me see next. So okay, okay, sorry, gamma is in xj, sorry, g xjz. Okay, so so here, okay, so this is definition. Sorry, this is definition of g of xy. Okay, so here so this is like if I have xjz, then I should get this subscript as this one, and v of xjz here, so that, okay, so I know that this z is basically being contained by definition, is contained in v xjz, and then basically by definition this is contained in this xj is being contained in, xj is in this u of xjz. Okay, so okay, why this the x is in wxj in u of xjz, y, let me see, if gamma is in this big gamma, and then gamma x equal to y for some pair of points. Okay, assume gamma x equal to y for some pair of points x, y in k. Okay, so here you have two points, right? You have x, you have a y, you have the complexity k, and then y is equal to this gamma x, and then we say that the x, okay, wait. Okay. Okay, so basically I think the idea is that we can pick, so because, okay, let's say that we pick the finite cover because this xj is an open cover, right? It's an open cover of this K. So take the index J and such that this X is contained in Wxj, right? Okay, so we first take an index. And now, so the point is, how do we really pick this y here? Okay, so once we pick an xj, right? So remember that this okay. Okay, maybe I want to say is that because this yeah. Okay, because I know that this case is actually, so actually this one is also a cover of this K, right? So what I can do is that, so then, okay, so then I can think accept. So y in this K implies that, so y is in one of the set, right? So it's in the union. So here I use these are like a double use index. So what I do is that, maybe I'll just say that, wait, hold on. Okay, I think here this x must be the same x as the index x. Okay, otherwise, yeah. Okay, so yeah. So for a fixed x, y x, z. Okay, yeah. Okay, so here, okay, so y is in K. This implies that, so y is in one of, so okay, so basically we fix this x to be xj, right? So here, okay, so this implies that y is in the union of, yeah, so this implies that y is in the union of this, let's say z in yxj of v of x j z. Okay, so this implies that this y is in the set v of x j z for some z in y x j. Okay, so now let's see what happened here. So, yeah, for some. Okay, so now we want to show that, okay, I think we have it, right? So because, so this is the vxjz, right? And then the only thing left is to show that, okay, of course that's this, since this y is in, oh, sorry. Yeah, so since, okay, so since this z is in this yxj, right? So z in this yxj implies that this W of xj is contained, right? Because it's an intersection. Okay, so contained in this, and then this, and also this z is because this Wxj is contained in the intersection of all the intersection over all the index. Intersection over all the uxj y, where y is in this index set, right? So now we pick a so now this z is in one of the index sets, so it is if this z is in one of these sets, this z is in one of these sets, so therefore this Wxj is inside that, okay, because it's intersection, okay. Okay, so now the idea is that, okay, so this Wxj is equal to, is contained in this u of xjz. Okay, yeah. So, okay, the only thing left is to show that this gamma is actually inside this g of xjz, right? So why this gamma is in this g of xyz? Because, because this intersection is non-empty by definition, right? Because this xj is in that, and then this z is in that. Wait. Sorry. So there's no problem of saying this, but the thing I want to say is that, so since so this okay, so we know that this Wj, which is contained in this set u of xjz, contain this x, right? So since right, so this x is in Wxj, and then Wxj is contained in this uxjz. We already showed that. So therefore, this x is contained in this u of xjz, and also we have already showed that this y is also contained in the vxjz. So we have that, and also gamma of x is equal to y, right? So therefore, this tells you what? This tells you that, let's say that this gamma x were, so this tells you that this side is not empty, okay. So then this implies that this gamma is in g of xjz. Okay, for some, okay. All right. So let me see next. So okay, so now, so it follows that, let me see. Oh. Okay, so now it follows that set gamma in this big gamma such that this gamma of k intersect k is not empty, which is contained in the set union j from 1 to n union z yxj of gxjz is a finite set. Okay, so okay, I want to show that it's a finite set, right? So so what is the reason that it's a finite set? Okay. Okay. Oh, okay. Wait. Okay, so okay. Okay, so if this gamma is gamma and gamma x equal to y for some period of point x, y, in x, y in k, x equal to w xj, and in this set u of xjz, right? And the y is in xjz, and the gamma is in. Okay, so yeah, because this we know we have already showed that this g of this xz is finite, right? Okay. Yeah. So this neighborhood are chosen such that this g is finite, right? So and then what happens is that okay, so this is a finite set, right? So this is a finite set. And then this z is what? Okay, no, sorry, not this z, but this y of xj is what? This y of xj. So remember, for each of its x, this y of x is a finite set, and such that this k is contained in that, right? So this set is also finite. And this is a finite union, so therefore everything is finite. And okay, so we want to show, so okay, so so y is contained in the set. Okay, so we want to show the containment. Okay, so namely, if I pick any, I want to show that. Okay, so that this gamma such that gamma k is non-empty. Okay. Oh, okay. Because wait. Okay, so then okay, so then so then what? So this means that so this implies that there exists a, because it's not empty, right? So yeah, so basically the idea is that I want to use this argument to make some conjecture because I know that these are like the open cover, right? So I can pick something that's okay. Let me just lay out the definition because yeah, because yeah. So this is like the yeah. So this is like the yeah. So this is like the global picture, right? So I want to like so if there is some point that's in this intersection, then that point must be both k and this gamma k there. So that basically that point must satisfy the condition that the gamma of something inside the k that's equal to yeah. So that point must be satisfied this gamma x equal to y, right? And I think this argument follows. Okay, I think that's the strategy. Okay, so let me see. So it implies that there is like a let's say y in this set, and then this implies that because y is in gamma k, right? So y in gamma k is simply as y equal to gamma of x for some x in this k, and also so for some x in k and also y is in k. So yeah, so this implies by the previous condition so this implies that this x is in wait. Okay, this gamma is in this G of xjz, right? Where this wxj is contained in set x, and this y, okay, and then this y is contained in this vxjz, okay. Okay, so yeah, so therefore it shows the containment relation. Okay, so I think that's a proof for this question because the question asks you to prove that okay, so yeah, because the question asks you to prove that this wait, question asks you to let me see okay, yeah, so remember that we want to show because the question says that so gamma okay, so on the one hand it says gamma x properly discontinuity on x, right? If and only if so pair of xy in X. So there is this neighborhood U of X and B of Y. Such that, okay, so such that gamma U intersect B is, okay, it's not, okay. Okay, gamma U intersect B is empty for our finally gamma U B. Gamma U intersect B is empty for all but phi. Okay. Yeah, such that this is not empty for finally many gamma. Okay. Okay. So now, what does this properly discontinuity mean? Okay. So this properly discontinuity means that, okay, so this means that, for all, so for all k in X compact, you have this gamma of k intersect k is equal to empty. Okay. It's not equal to empty for finally many gamma and gamma. Okay. Okay. I think this shows you the, yeah, so namely this set is finite, right? Namely this set is finite. Okay. Okay. Yeah, so we assume, okay. Oh, okay. Okay, yeah. Remember we start with this assumption, right? So we define this set under this assumption, and then finally we prove the result under this assumption. So yeah, so I think that's the proof. Okay, that's the proof. Okay. All right. So let me okay, let me see. Okay, so now we are ready to move on to the next part. Okay. Okay, so theorem. Let this gamma from x tilde to x with okay, so that gamma from this x tilde to x is a universal covering space of a connected locally simply connected okay, okay, so and then locally compact Hopsell space X. Okay, so locally semi-connected means that okay, like for each one there's a open set that's there's a simply connected there's a simply connected neighborhood. Okay, and then okay, and then this locally compact means that for each point there is a for each okay, let me see if I get it. So for each point P, there's a neighborhood U of this P such that for each point P and each neighborhood U of P, there is a relatively compact set V that that is containing the point P that is also contained with U. Let me see if it's correct. Okay, yeah, it's correct. Okay, and then what about the so locally simply connected? Okay, we said X is local simply connected if for every point P X and every neighborhood U of P, there is a simply connected neighborhood V of P U. Okay. Yeah, sorry, I was wrong for the locally simply connected. So, yeah, so basically for each one P in X and every neighborhood U of P, there exists a simply connected neighborhood V of P in this U. Okay. Alright, so yeah, so these are the definitions for the locally simply connected and locally compact. Yeah. Okay. So and then okay, then this gamma, big gamma, which is being defined as the deck transformation